Hi, this is Team Fire Force, and this is the results from our senior project. So to start out with, there was our final project slide. Alright, so to start out with, here is two parts of our project working together in unison. This is both the localization and the human detection. Now, if you notice the localization, there is only one tag. Now, right here, this is shown with 3 tags. We implemented 3 moving tags for the DECWAVE sensors, but for the purposes of human recognition, we only need to work with 1. So here it is with visual aids. Going back to the project, what you see on the left is the mobile tag moving around. We are assuming that there's a human near each of the anchors, which is a box, and on the right you can see that a human is being detected at specific coordinates. Now David will be showing off his part with the consensus algorithm.
The purpose of the consensus algorithm is to provide an efficient, and we could even describe it as a coherent way for a group or a network, and sometimes it's referred to as a mesh or a swarm of agents, and in our case these agents are turtlebots. And so the consensus algorithm provides a way for these agents to work together in a coordinated and a controlled manner. And the two-dimensional multi-agent consensus algorithm that we use actually accounts for both the real-time position and the real-time heading of the turtlebots. And it actually utilizes what's known as a feedback loop. And so, more formally stated, in other words, our consensus algorithm actually incorporates both position and heading consensus. And so, as a result of this, the 3 agents, in our case again, the turtlebots, they are able to converge, or they're able to gather or get to a common location. And then from that common location, they are able to travel in a designated user-specified formation, regardless of where the turtlebots were initially placed or what their initial heading was. And so this actually makes it possible for the swarm or the group of turtlebots to actually scan a large area in a controlled, and you could say sort of this coordinated way, to accomplish various tasks, some of which include reconnaissance, hazard identification, and even risk assessment. So here is a quick demo demonstrating how user-friendly and easy our software is to use. First, we run the launch file that creates a node for each of the turtlebots, and then we go on to run the actual consensus algorithm. In the terminal window, we are then prompted to choose a formation we want the turtlebots to be in. And then after we choose the formation of our choice, we actually see in the terminal window for each of the 3 turtlebots, we are given data such as the desired position, the desired velocity, and the desired heading of that turtlebot, as well as the sampling time or the time interval used to generate this data. If we take a closer look at the turtlebots actually converging to a common location, then we do in fact see that if this is a control system, then we can describe it as an underdamped system, meaning that the agents or the turtlebots, once they sort of get into position, there will be sort of this slight overshoot and undershoot by each of the turtlebots, and of course this overshoot will settle out to the steady state, and this happens relatively quickly, but there is still that small overshoot that we have to account for. And this is it. This is the consensus algorithm that we developed in action, and hopefully you guys enjoyed watching it. Thank you very much.
In this project, we also focus on the decentralized algorithm. Each robot will be able to make the decisions on its own. Recent advantage in technologies has increased the capability of mobile platform while decreasing the cost. It's become more feasible to create and deploy a large number of inexpensive agents to cooperative accomplishment objects than just one expensive centralized system. With the centralized system, the failure of one agent or subsystem can cause a mission failure. The multi-agent system we develop here provide many advantages such as lower costs and robustness to agent failure. The multi-agent system may also provide improved performance and solve new problems that traditional systems did not adequately solve. The robustness provided on decentralized system is due to the fact that the failure of a single agent usually does not result in the overall mission failure.
The final part of the project we will be showing is not a core requirement of the final product, but rather the potential for it to be implemented as we originally saw with the hardware. So what you'll be seeing is the robot itself moving to a specified position using the deca waves to determine where to go. As you can see right now, it's moving. We chose to have it move to the center of the room, and it's using the deca waves to navigate. Thank you for watching our final results of the project, and we'd like to say a special thank you to the school, Professor Tolentino, and our sponsor, Dr. Michael McCourt.